A particle moves along a straight line. After t seconds, its displacement in meters from a fixed point on the line is given by s equals t squared into bracket 5 minus 2 root t, where t is between 0 and capital T, where capital T is the time at which the particle comes to rest. A. Find expressions in terms of small t for the velocity and acceleration of the particle after t seconds. And then B. Find the value of capital T. So this displacement is given as s equals t squared times 5 minus, instead of 2 root t, I'll write 2t exponent 1 over 2. So we are supposed to find the velocity. I will know that the velocity v is equal to ds dt, which can also be written as s prime of t. So let's find s prime of t. This is equal to, this is the product of two functions. For example, f of x equals g of x plus times h of x, g of x, h of x. So this means that f prime of x equals, so let me cancel this, f prime of x is equal to differentiate g of x to get g prime of x and keep h of x, and add it to keep g of x and differentiate h of x to get h prime of x. So in this case, s prime of x is equal to, our g of x is t squared and h of x is 5 minus 2t exponent half. So g prime of x is 2t. Then we multiply by h of x, which is 5 minus 2t exponent half. Then plus g of x. G of x is t squared. And multiply by, if we differentiate this, if you differentiate 5 is 0. So minus 2 times 1 over 2, then times t exponent. 1 over 2 minus 1 is minus 1 over 2. So this is equal to, let's multiply through, 2t times 5 is 10t. Then 2t times minus 2, we get minus 4t. And this t is exponent 1 plus 1 over 2. 1 plus 1 over 2 is 3 over 2. Then plus these 2 and these 2 can cancel. So minus 1 times t squared becomes minus t, then t exponent 2 minus 1 over 2 is minus t exponent 3 over 2. So this is equal to 10t minus 4t exponent 3 over 2 minus t exponent 3 over 2 equals minus 5t exponent 3 over 2. So this is the expression for the velocity s prime of t. Please, I made a mistake. This is s prime of t. So s prime of t. Then let's find the acceleration. The acceleration is s prime prime of t. And this is equal to, so let's further differentiate this. If you differentiate 10t, you get 10 minus, if you differentiate this part, you get minus 3 over 2 times 5. Then t exponent 3 over 2 minus 1 is equal to 1 over 2. So this is equal to 10 minus 3 times 5 is 15 over 2t exponent 1 over 2. Then the last part of the question says we should find the value of capital T. But from the question says that capital T is the time at which the particle comes to rest. So S of t is equal to t squared into bracket 5 minus 2t exponent 1 over 2. And S prime of t we got as 10t minus 5t exponent 3 over 2. And he says we should find the value of capital T. But capital T is the time at which the particle comes to rest. So it means that S prime of capital T is equal to 0. So let's find S prime of capital T. This is equal to 10t minus 5t exponent 3 over 2. So at the point where the particle comes to rest, the velocity is 0, and therefore 10t minus 5t exponent 3 over 2 is equal to 0. So let's factorize 5t out. We'll be left with 2 minus t exponent 1 over 2 is equal to 0. But we know that capital T cannot be equal to 0. The reason is because if capital T is 0, it means that the particle never moved, so it didn't come to rest in the first place. So therefore, the only thing that can be 0 is 2 minus t exponent 1 over 2 is equal to 0. So t exponent 1 over 2 is equal to 2. So we can square both sides. So this becomes t equals 2 squared. So capital T is equal to 4 seconds. The radius of a spherical balloon is increasing at the rate of 3 centimeters per second. Find the rate of increase in the surface area of the balloon when the radius is 10 centimeters. So now, the radius is increasing at 3 centimeters per second. So this is the r dt equals 3 centimeters per second. Find the rate of increase in the surface area. So we are looking for the a dt of the balloon when the radius is 10 centimeters. So let's write a formula that links the a dt and then the r dt. So we know that the a dt is equal to the a dr times the r dt. Now let's find the area of a sphere. The area of a sphere is given as 4 pi r squared. So from here, what is the a dr? It is equal to 2 times 4 pi r. So the a dr is equal to 8 pi r. So we found the ADR, then we found the ADR and we know the RDT, so we can find the ADT. So the ADT is equal to the ADR, which is 8 pi r, times the RDT, and the RDT is 3 centimeters per second. So the A dt is equal to 8 pi times the radius, and the radius is 3 centimeters. Sorry, the radius is 10 centimeters. So times 10, then times 3. So the A dt is equal to 8 times 10 is 80. 80 times 3 is 240, so it's 240 pi centimeter squared per second. Find the equation of the tangent to the curve y equals 7x minus 4x squared at the point where x is equal to 1. So y is equal to 7x minus 4x squared. Let's find the y component, but x is equal to 1 at that point. So y of 1 is equal to 7 times 1 minus 4 times 1 squared. This equals 7 times 1 is 7 minus 4 times 1 squared is 4. 7 minus 4 is 3. So the point at which the tangent touches the curve is 1 and 3. So let's then go ahead and find y prime of x, which is the gradient. And then y prime of x is 7x minus, is 7. If you differentiate 7x, you get 7 minus 8x. Let me write it again. Y prime of x is equal to 7 minus 8x. But the point is x equals 1. So let's find y prime of 1. Is equal to 7 minus 8 times 1. This is equal to 7 minus 8. And therefore y prime of 1 is equal to minus 1. So this implies that the gradient m is equal to minus 1. So we have the point, we have the gradient, so we can find the equation of the tangent. So y minus y1 is equal to m x minus x1. So y minus y1, which is 3, is equal to m minus 1 times x minus x1 is 1. So let's distribute. Y minus 3 is equal to minus 1 times x is minus x. Minus 1 times minus 1 is plus 1. Here's 3. So let's take all of this and send it to the left hand side. The volume of a sphere is increased by 6%. Calculate the corresponding percentage increase in its area. So with the volume is increased by 6%. So what is the increase in volume? Is just 6 over 100 times the original volume, V. So let's find the volume of a sphere. Volume of a sphere, V, is giving us 4 pi r cubed. Volume of a sphere is giving us 4 over 3 pi r cubed. And therefore the increase in volume, delta V, is 6 over 100 times 4 over 3 pi r cubed. So what is the value of delta V? Delta V is equal to 0.08 pi r cubed. So now let us write a formula that links both the volume of a sphere to the area of the sphere. But we know that dV dA is equal to dV dr times dr dA. So let's write the volume of a sphere and find dV dr. Volume of a sphere is given as 4 over 3 pi r cubed. So dV dr is equal to 3 times 4 over 3 pi r squared. So this 3 and this 3 cancel. So it will give us 4 pi r squared. Now let's write the formula for the area of a sphere. The area of a sphere is equal to, or is giving us 4 pi r squared. So what is dA dr? It is equal to 8 pi r. But in the question we are looking for the r dA. So the r dA is just going to be 1 over 8 pi r. So we found dV dr and we've also found the r dA. So we can go ahead and find the dA. So divine the A is equal to divine the R, and divine the R is 4 pi R squared times the RDA, and the RDA is 1 over 8 pi R. So divine the A is equal to 4 pi will cancel 8 pi twice, and this R will eliminate one of the R, so it's just going to be R over 2. So this is divine the A. However, we know that we are looking for the A, which is the percentage increase in its area. The A is the increase in area. So the increase in area is equal to 2 over R times divine. Divine is the same as delta V. So the A is equal to 2 over R times divine delta V, which is 0.08 pi R cubed. So one of this R will cancel an R here, so that the A is equal to 0.16 pi R squared. But the question says we should find the percentage increase in the area. The percentage increase in the area, so percentage increase in delta A is equal to the A over the original area times 100%. So this is equal to 0.16 pi R squared. Then area of a sphere is given as 4 pi R squared times 100%. So pi R squared and pi R squared will cancel. So we'll be left with 0.16 times 100% divided by 4. And this is equal to 4%. Find the equation of the tangent to the curve y equals 1 over x plus 1 when x is equal to 1. So the value of x is 1. So let's just find y of 1. It's equal to 1 over 1 plus 1. And this is equal to 1 over 2. So the point at which the tangent touches the curve is 1 and 1 over 2. But y is equal to 1 over x plus 1. So let's find y prime of x. So let's find y prime of x. It's equal to, we need to use the quotient rule in this case. Okay, so another way we can do this is we can write it as x plus 1 exponent minus 1. So y prime of x is equal to, differentiate what is inside the bracket. If you differentiate x, you get 1. And if you differentiate 1, you get 0. So it's 1 times, you repeat what is in the bracket, x plus 1. Then you multiply by, let me start the whole thing again. So y prime of x is equal to, differentiate what is inside the bracket. You get 1 times, bring the power down, minus 1 times all that is in the bracket, x plus 1. Then you subtract 1 from the power, minus 1 minus 1. So this is equal to minus into bracket x plus 1 exponent minus 2. So y prime of x is equal to minus 1 over x plus 1 squared. So the point is x is equal to 1. So let's find y prime of 1. This is equal to minus 1 over into bracket 1 plus 1 squared. So 1 plus 1 squared is 2 squared. And this is equal to 1 over 2 squared is 4. So minus 1 over 4. This then implies that the gradient is equal to minus 1 over 4. So we have the point, and write it well. The gradient is equal to minus 1 over 4. We have the point 1 and 1 over 2, then the gradient. So the equation y minus y1 is equal to m into bracket x minus x1. So y minus y1 is 1 over 2 equals m. The gradient minus 1 over 4 times x minus x1 is 1. So let's multiply through by 4. 4 times y is 4y minus 4 times 1 over 2 is 2 equals minus 1 times x minus 1. 4y minus 2 is equal to minus 1 times x is minus x. Minus 1 times minus 1 is plus 1. So we bring x to the left hand side of the equation, we get 4y plus x minus 2 plus x minus 2 minus 1 equals 0. So we get 4y plus x minus 3 is equal to 0. The equation of the normal to the curve x squared plus xy plus 2y squared equals 8 at the point minus 3 and 1. So what we need to do is to find dy dx. So the curve is x squared plus xy plus 2y squared is equal to 8. We have been given the point. If you differentiate x squared, you get 2x. Now plus, this is product of two functions. So you keep x, you keep y and differentiate x. If you keep y and differentiate x, it will be 1 times y, which is y, plus you keep x and differentiate y. If you differentiate y, it is dy dx. And then plus, if you differentiate 2y squared, you get 4y dy dx equals, if you differentiate it, is 0. So let me cancel this and write it well. So it is 2x plus y plus x dy dx plus 4y dy dx is equal to 0. So let's group like terms. So in this bracket we have 2x plus y plus, I want to factorize the y dx out. So below it x plus 4y dy dx is equal to 0. So we have x plus 4y dy dx is equal to the minus 2x plus y. So dy dx is equal to minus 2x plus y divided by x plus 4y. So therefore, let us then go ahead and find the value of dy dx at the point minus 3 and 1. So at minus 3 and 1, what will be the value of dy dx? Wherever we see x, we put minus 3, and wherever we see y, we put 1. So minus 2 times x, x is minus 3, plus y is 1, divided by x minus 3 plus 4 times y is 1. So this is equal to minus 2 times minus 3 is 6 plus 1 divided by minus 3 plus 4. And this is equal to 6 plus 1 is 7. Minus 3 plus 4 is divided by 1. So 7 divided by 1 is 7. And therefore dy dx is equal to 7. So we found the gradient m equals 7. However, he says that the equation is normal to the curve. It means that, let's assume this is MC, which is the gradient of the curve, is equal to 7. Since they are normal, it means, since it is normal to the curve, it means that it is perpendicular to the curve. And then the gradient of two perpendicular lines, the product of the gradient of two perpendicular lines is -1. So MC, the gradient of the curve, times the gradient ML of the line is equal to -1. So 7 ml is equal to -1. And therefore the gradient of the line is -1/7. So we have the point, we have the gradient. So let's go ahead and find the equation. The equation is y minus y1 equals mx minus x1. So y minus y1 is 1 equals m minus 1/7 times x minus x1 minus -3. So let's multiply through by 7. We'll get 7 times y is 7y minus 7 times 1 is 7 equals -1 times x minus -3 becomes +3. So we'll get 7y minus 7 is equal to -x minus 3. So let's bring everything to the left hand side. We'll get 7y plus x. Then -7 plus 3 becomes -4 is equal to 0. This is the equation of the line. The equation is x y cubed minus 2x squared y squared equals 0. Find the gradient of the tangent to the curve at 1, 2. So this is the equation: x y cubed minus 2x squared y squared equals 0. So let's find the y dx, which is the gradient of the tangent. So if we differentiate these two, this is product of two functions. It says keep x and differentiate y. If you differentiate y cubed, you get 3y squared dy dx. Then add it to keep y and differentiate x. If you differentiate x, you get y. 1. 1 times y exponent 3 is y exponent. So let me cancel it and then write it well. So we have 3x y squared dy dx plus y cubed minus 2 into bracket. So keep y squared and differentiate to x squared, you get 2x y squared. Then add it to keep x squared. So keep x squared, then you differentiate y squared. If you differentiate y squared, you will get 2y dy dx equals, if you differentiate 0, 0 is a constant, so it will give 0. So equals 0. So let's go ahead and expand. So 3x y squared dy dx plus y cubed minus 2 times 2x y squared is 4x y squared, then minus 4x squared y dy dx is equal to 0. Go ahead and then group like terms. So this becomes 3xy squared dy dx, then minus 4x squared y dy dx is equal to, and you bring this term across the equation to give 4xy squared then minus y cubed. So let's factorize the y dx. So this will give us 3xy squared minus this term, which is 4x squared y dy dx is equal to 4xy squared minus y cubed. So we can go ahead and divide both sides by 3xy squared minus 4x squared y. Divide this side too by 3xy squared minus 4x squared y. So this and this cancels out, so that the y dx in this case is equal to 4x y squared minus y cubed divided by 3x y squared minus 4x squared y. So let's further simplify. You can factorize y out of the equation, so that the y dx is equal to, if you factorize y out of the numerator, you get y times 4xy minus y squared divided by, if you factorize y out of the denominator, you get y times 3xy minus 4x squared, so that this y and this y can cancel. So at the end of the day, the y dx is equal to 4xy minus y squared divided by 3xy minus 4x squared at the point 1 and 2. So the y dx is the same as the gradient. So the gradient m is equal to, wherever you see x you put 1, and wherever you see y you put 2. So this becomes 4 times 1 times 2 minus y squared, which is 2 squared, divided by 3 times 1 times 2 minus 4x squared, which is 4 times 1 squared. So 4 times 1 is 4, 4 times 2 is 8, minus 2 squared is 4, divided by 3 times 1 is 3, 3 times 2 is 6, minus 1 squared is 1 times 4 is 4. 8 minus 4 is 4, divided by 6 minus 4 is 2, and this is equal to 2. So this implies that the gradient to this curve at 1, 2 is 2.